Routine class project demonstration. When using the UAR get code by to get a code value, the routine could potentially not find the value. In that case, the routine returns a -1. The program does not return an error but continues processing. This could cause missing data or no results found. For more clarity in these situations, we will create a subroutine that can be called to validate the UAR is returning a code value. The subroutine should return a code value if found, a 0.0 with a warning showing CCL-W, or fail with an error showing CCL-E if the code value is not found. Also allow the programmer to determine if the warning or error is returned at runtime. Call the subroutine when populating a variable to contain the code value for a BUN orderable, and verify the subroutine is working. Flex the parameters to see the difference in the output. How can you make this subroutine available to all of your programs that declare variables using UAR get code by? Have you experienced this issue before? The report used to run, returning data, and now it doesn't. After further research, you find for various reasons the UAR get code by is failing. It would be beneficial for a program that is not returning data to give some indication why. Let's build the subroutine specifically to address when the UAR get code by is failing and not returning the expected code value. I have dvdev open and a program created. This prompt program declares a variable called BUNVAR, populated with a code value for the BUN orderable, using the UAR get code by routine. This UAR expects 3 parameters. The first is the string type of meaning, display, display key, description, or concept CKI. The second is the code set of interest. The third is the case-sensitive text of interest from the code set. Specifically for the BUN, which is the blood urea nitrogen orderable, the parameter passed to the UAR are display key. Display key is the chosen string type since the meaning in this code set is not populated. The code set that stores the orderable name information, which is 200, and the case-sensitive text is uppercase BUN. The query is gathering order information for orders placed in the past 30 days, specifically looking for where the O.catalog code is a BUN orderable. This program could be set up for a user to run from Discern's reporting portal. Let's run the prompt program as a user would to review the output. The report returns BUN orderbles in the date range as expected. The UAR returned the code value and the qualification found the rows for display. What does the user see if the UAR fails? This issue does not present itself in a way that makes it obvious what went wrong. To demonstrate, I'm adding an N to BUN. Since there is not a BUNN stored in cache memory, this UAR will fail. Saving, compiling, and running the program with the flawed parameter. This time the message "No output returned" is displayed. There are no errors or warnings providing any indication of what went wrong, just no data. For a user whose job it is to simply run the report, no output returned isn't providing any useful information on what went wrong or how to proceed. They can only report the report just doesn't work. Some investigation clears up the mystery. Let's echo out what is currently in BUNVAR. The call echo bun var is placed directly after the declare command. The output of a call echo using dvdev is placed in the listing file after a program has run as a command. Scrolling to the bottom of the file, the object name, any required prompt parameters, and go can be placed temporarily after the end go or in a separate file with the command. The program is executed as a command using include compile. I have this command placed after the end go. Okay, we have the object name passing in NL : to pass to $outdev and go. Uncommenting the command, saving and executing the program using include compile. No errors received. Accessing the listing using View Listing. Control-L is also available to get to the listing file. Scrolling past the code to the end where the program was called. The bun var variable contains a -1 as expected. The value of bunn was not found in cache memory and returned a -1 to populate bun var. The -1 was used in the qualification and o.catalog code equals -1. No rows were found in the orders table for the date range with a value of -1. The program did not error, it just didn't find any matches. A -1 could be returned by the UAR get code by when no match found in cache memory or multiple matches found in cache memory. As demonstrated, a user running a report with the UAR failing will only be able to report that the report just doesn't work. An indication that the UAR failed would be helpful in this case. We could build a subroutine to provide helpful information when the UAR get code by is not working as expected. An outline of the logic for the subroutine will go something like the following. Declare a variable that calls the UAR get code by, checks the value returned to the variable, add conditional logic that returns the code value if the code value is found, returns a 0.0 if the code value is not found, and determines if a warning or an error message is issued. Once the subroutine is created, we will call the subroutine instead of the UAR get code by to populate the variable. I plan to use the Add Subroutine Builder for this demonstration. You could choose to use the builder or manually type the commands in the file. Clicking under the comment dvdev defined subroutines. If the comments are not in the file, click where you want the definition to be placed. From the Tools menu, choose the Add Subroutine Builder. Let's give the subroutine a user-defined name. I'm calling it Check Code Value. The goal of this subroutine is to return a code value if the UAR is successful and a 0.0 if unsuccessful. What data type should we choose for the return type of this subroutine? Code values and 0.0s are F8s and is the return type. The combine subroutine and declare syntax option is defaulted. The start of the subroutine definition is created. A question to answer from the requirements of this class project is, how can you make this subroutine available to all of your programs that declare variables using the UAR get code by? If this subroutine will be accessed in multiple programs, you could create a child script with this definition and choose the With Copy option. Then the child script could be called from the parent, pulling in the subroutine into scope. Good information. Let's move on to adding parameters. Clicking Parameters. How many parameters does the check code value subroutine need? Let's see. 3 parameters are needed to pass to the UAR get code by. 1 more parameter is needed to flex whether a warning or an error is issued. A total of 4 parameters are needed. Let's build the 3 parameters needed for the UAR get code by first, and then the parameter for the warning or error. Clicking Add. We define a name for the first parameter to be passed to the UAR. Let's call it Type. What is the data type of type? Meaning, display, display key are some choices that could be passed to type. VC does work for this parameter. The Add Parameter box is where you could choose to utilize passing in a value by reference or by value, and provide a default value to the parameter. We will require the parameters to be passed to the subroutine when it's called for this example. We are done with the first parameter, clicking OK. There are 3 more parameters to build. The second parameter for the UAR get code by is the code set. The parameter needs a name and a data type defined. I plan to call it code set and provide the data type as an I4. Clicking Add and filling out the name and data type. This looks good for the second parameter. Clicking OK. The third parameter for the UAR get code by is the actual text. The parameter needs a name and a data type. I plan to call it text and provide a data type of VC. This looks good for the third parameter. Clicking OK. The fourth parameter is controlling if a warning or an error is issued. The parameter needs a name and a data type. I plan to call it eFlag and provide a data type of C1 to allow an E or a W. Choosing the C parameter type opens access to provide a specific width. This looks good for the fourth parameter. Clicking OK. The 4 parameters for the subroutine are complete. Clicking OK. The Add Subroutine Builder created the first part of the syntax for us. Next is to build the logic. Let's exit the builder to do this work. Clicking Add. Clicking Add on this part of the builder writes the subroutine to the file. Exiting the builder by clicking Close. The structure for the subroutine is created. End terminates the subroutine. For clarity of what this end is for, adding a comment to the end command. Now for the logic. What work does the subroutine need to do? The subroutine needs to declare a variable that calls the UAR get code by for a BUN orderable, evaluate the return of the UAR and return a value, add logic to evaluate for a warning or an error message. Okay, declaring a variable first. I am calling it codevar. Codevar will return a code value, which is an F8. populating the variable by calling the UAR and passing in the three parameters. Using no constant, calling the UAR, and passing in the parameters type, code set, and text as defined in the subroutine definition. What syntax can be used to evaluate what is returned by the UAR? Does using the if and if come to mind? Let's try that idea. We are evaluating what is in the code var variable. Okay, added the code var. We are checking to see what value was returned to the code var variable. It could have a code value or a negative number like -1, indicating that something went wrong. Handle each return possibility separately. Let's handle the logic for if the UAR does not work as expected and does not return the code value. Adding to the condition to check if the value is less than 0.0. If the code var is less than 0.0, the UAR is unsuccessful. What should happen in this case? The requirements state to return a 0.0 if the code value is not found. Add the return and return 0.0. The next requirement is to allow the programmer to flex if an error or a warning is issued. How can this information be determined? Remember the E flag? The check code value subroutine is expecting a W or an E to be passed to it. Are you thinking about somehow using conditional logic to check for a W or an E? Yes, let's try that and add the conditional logic above the return command. Once the return command is executed, processing exits the subroutine and continues processing where the call occurred. So any commands needed for the logic must be placed above the return command. Adding the conditional logic to check for a warning first. Okay, we want to flag a warning with a helpful message. What function can we use to provide a warning message? This is a good place to try out the call CCL exception. Adding the call CCL exception to create a warning. Call CCL exception, passing in 901 as the number, W for the warning, and the message, warning, code value not found for BUNVAR. Okay, the warning is handled. What logic should be added if an E for error is passed to the subroutine? More conditional logic? Yes, it is an alternative check and pathway that can be handled with an else-if statement. Using the else-if to check for the E, and then using the call CCL exception to issue an error message. Using else-if to check if E is getting passed. If it is, then using call CCL exception, passing in 902 for the number, E for error, and the message error code value not found for BUNVAR. The warning and error handling logic is complete. What would be the difference in choosing a warning over an error? The error will present itself as an error box to the user who is running the prompt program. The warning will not provide the error box, but will land in the output messages or possibly log files depending on traces configured in the domain. The process of how the program is executed should be evaluated to determine which might be better to use. One last bit of logic is needed. The subroutine now needs the logic for when the UAR works as expected. In that case, what value should be returned? Yes, a code value. For this logic, we can add an else to the main conditional statement to handle if the code var is greater than 0.0. In the else part of the logic, adding return and passing in the code value represented by code var. Okay, if the UAR is successful, the code value is returned. The logic in the subroutine looks complete. Now to call the subroutine when the UAR get code by is called. Scrolling back to the top of the file to where the BUN var is declared. The BUN var is declared and is using the UAR get code by. Replacing the UAR get code by with the subroutine check code value. The subroutine currently has 3 parameters being passed. The subroutine is expecting a 4th parameter to issue a warning or an error if something goes wrong. Currently, BUNN is the 3rd parameter, which is causing a problem. Let's test the warning by passing a W as the 4th parameter. Great, this logic is complete. It's time to test the subroutine. We have 3 scenarios to test. A call to the UAR get code by that fails with a warning, a call to the UAR get code by that fails with an error, and a call to the UAR get code by that is successful and passes back the code value. The program is set to test the failed UAR attempt with a warning. The object name NL:\go is placed after the end go, saving and then compiling to execute the program. The output message shows the CCL-W-392 showing the call CCL exception using 901, warning code value not found for BUN var. Warnings show in the output message when the program is executed as a command from dbdev, or depending on the set trace warnings configured for the domain, the warnings could show in server log files. However, warnings are not displayed to the user for a run prompt program. Running the prompt program to demonstrate the behavior of the warning and what the user sees. No output returned, and no ability to see the warning. If the set trace warnings are configured in the domain, the warning could be found in the server log files. Sending a warning to a log file might be a preferred method, depending on how the program is executed and the architecture of the process. Since no warning box is displayed, maybe an error is a better choice for when the program is run as a prompt program. Let's test this process by specifying an error, changing the W to an E in the declare statement and then executing the program. Okay, the output message is showing the CCL-E-392 with the call CCL exception, number 902, error code value not found for BUN var. Let's run the prompt program to see the behavior of an error. Loud and clear, the error message presents itself to the user that something went wrong with the BUN var variable. Failed to execute the report, providing the CCL-E and the error message. Now this message is providing a clear understanding of what is going on with this report. Selecting OK to the message. The warning and the error are working as expected. Let's test the last scenario when the BUN var is successful, changing BUNN to just BUN. Now saving, compiling, and executing the program. Zero errors. Now running as a prompt program. Great, we have a report that shows information for blood urea nitrogen orders placed in the past 30 days. It looks like the subroutine worked as expected. In review, we defined a subroutine that requires 4 parameters. Each parameter has a defined data type. The subroutine is returning an F8. The logic has a variable that is populated by calling the UAR getCodeBy, passing in the parameters as defined by the subroutine definition. Following the declare is conditional logic that determines what is returned and a possible warning or an error if the UAR call fails. The subroutine is called in place of the UAR getCodeBy in the declare statement that populates the BUN var variable. This concludes the subroutine demonstration. Thanks for watching.